Reciprocal trig functions. Here we're talking about cotangent, cosecant, and secant. Cotangent is the reciprocal function for tangent. So cotangent of any angle measure theta is the same thing as saying 1 over the tangent of theta. So if you're ever asked to round the value of the cotangent of an angle, you would type it into your calculator as a fraction, 1 over the tangent of that angle. If you're ever asked to find the cosecant of an angle, you would type it into your calculator as 1 over the sine of that angle. And for secant of an angle measure, you would type it into your calculator as 1 over the cosine of that angle measure. So there's a few different ways that we could think of these if we're talking about a unit circle. We know that the tangent function is the same thing as saying the sine of the angle measure over the cosine of the angle measure. So that means the cotangent function is the same thing as saying the cosine of that angle measure divided by the sine of that angle measure. It's the inverse of the tangent function. Another way to think of the cotangent in terms of just a right triangle when we're talking about SOHCAHTOA, since the tangent of an angle is the opposite over the adjacent, the cotangent is the adjacent over the opposite. And finally, when thinking in a unit circle using our special right triangles, we can think of it as x over y, which is the same thing as saying the cosine of theta over the sine of theta, because the x value is the cosine value and the y value is the sine value. For cosecant, we can think of it as the hypotenuse over the opposite, because the sine is the reciprocal of that. Another way we can think of it is 1 over the y value, which again makes sense because the hypotenuse is 1 and the y value is the sine value, 1 over the y value. For the secant, you can think of it as the hypotenuse over the adjacent, which again makes sense because cosine is adjacent over hypotenuse, it's the reciprocal. Or we can think of it as 1 over the x value in the unit circle because the x value is the cosine value. So here we have a few examples. Now to do these examples, I am going to change the angle measures from radians into degrees just so that it's easier for you to see on the unit circle where the terminal side of the angle is. Here we're finding the exact values. If we just wanted to find any rounded values for these top two examples, we would type it into the calculator in radian mode. This would wind up being 1 over the cosine of 5 pi over 4. And this would wind up being 1 over the tangent of pi over 3. These bottom two examples would be typed into the calculator in degree mode. This would be 1 over the sine of 30 degrees, and this would just be tangent of 135 degrees. However, here, since we're being asked to find the exact values, I'm going to change that 5 pi over 4 into degrees by multiplying 5 pi over 4 times 180 over pi. Cross-canceling a little bit, the pi values cancel out. 4 goes into 180 45 times, and then the 45 times the 5 is going to give me a 225 degree angle measure. So this is a 225 degree angle measure. So if I were to sketch this on my unit circle, this is my initial side. My terminal side, well, from here to here would be 180, from here to here would be 270. So that means that 225 is going to be somewhere in between those. So this is my 225 degree angle. Now I'm going to work with a special right triangle. If this is 225 degrees and this is 180, that means that I went an extra 45 degrees. So my angle measure here is 45 degrees, and I'm going to look at this as a right triangle. So my right triangle, I have a 45 degree angle here, which means this also must be a 45 degree angle. My hypotenuse is the radius of the unit circle, so that's a 1. Since in a special right triangle, the hypotenuse is x times radical 2, and the other two equal sides, opposite the equal angles, are x, I could set up some sort of equation, x times radical 2 equals 1. Solve for x. When you rationalize the denominator, you wind up getting that each side is radical 2 over 2. Now, since the x value, the cosine value, is going left, that's a negative cosine value. So this is going to be a negative radical 2 over 2. And since I'm going down, the sine value is also going to be negative, so negative radical 2 over 2. Since secant of any angle is the same thing as saying 1 over the cosine of that angle, that's like saying 1 over the x value. So 1 over negative radical 2 over 2. When you keep change flip, that's going to give you negative 2 radical 2. Finally, to rationalize the denominator, we're going to multiply the top and bottom by radical 2 over radical 2. And we wind up with a final answer that the secant of 5 pi over 4 has an exact measure of, this is going to give me 2 radical 2. In the bottom I get a radical 4, which is 2. So you wind up getting 2 radical 2, negative, over 2. So the 2's cancel, and I'm left with just a negative radical 2 as my final answer. Looking at the cotangent example, again, I'm just going to change those radians into degrees just so it's easier for you to sketch on your unit circle. So pi over 3 times 180 over pi. The pi values cancel. 3 can cross cancel with 180. It gives you a 60. 60 times 1 is just 60, so this is 60 degrees. So I'm going to sketch my 60-degree angle. And here it's going to be fairly simple. We're creating a right triangle. If this is 60 degrees, then this has to be 30 degrees. My hypotenuse is my radius in my unit circle. The side across from 30 is half the measure of that. The side across from the 60-degree angle is radical 3 over 2. Because in a 60, 30, 90 right triangle, the side across from the 30-degree angle is x, the side across from the 90-degree angle is 2x, and the side across from the 60-degree angle is x times radical 3. Since the cotangent of any angle is the same thing as saying the opposite, the reciprocal of the tangent function, we said before that it was the cosine of an angle over the sine of an angle, because tangent is sine of an angle over cosine of an angle. So the cosine value, the distance that we're going horizontally, is a positive 1/2, and that's over the sine value, which is radical 3 over 2. Keep change flip, you're going to get 1/2 times 2 over radical 3. The 2's cancel and you get 1 over radical 3, but again I want to rationalize that denominator. So I'm going to multiply the top and bottom by radical 3. I get radical 3 over 3, and that's what the cotangent of pi over 3 equals. For my next example, the cosecant of 30 degrees. So the 30 degrees is fairly simple to sketch on my unit circle, and then I'm going to make a right triangle out of it again. So this is going to be a 30, 60, 90 right triangle, where the hypotenuse is the radius of the unit circle, so that's a 1. Across from the 30-degree angle is going to be my 1/2. And then across from the 60-degree angle is radical 3 over 2. All positive values because it's in the first quadrant. Now we know that the cosecant of an angle is the same thing as 1 over the sine of that angle, which is the same thing as saying 1 over the y value. So this is going to be 1 over the y value, which is 1/2. When we keep change flip, we get 1 times 2 over 1, which means 2. So the cosecant of 30 degrees, make sure you have the degree symbol in there, is 2. Lastly, for tangent of 135 degrees, I'm going to sketch my 135-degree angle. I'm going to use the reference angle. So I'm going to use this 45-degree angle to create a 45, 45, 90 right triangle. My hypotenuse is the radius of the unit circle, so that's a 1. I'm going radical 2 over 2 units up, but negative radical 2 over 2 units left. We know that the tangent value is the sine of theta over the cosine of theta. So it's the y value, which is radical 2 over 2, over the x value, negative radical 2 over 2. When we keep change flip, that's going to give us radical 2 over 2 times negative 2 over radical 2. The 2's cancel, the radical 2's cancel, and I'm left with a negative 1 as my final answer for the tangent of 135 degrees. Again, we can type all of these into the calculator to check. Now these obviously you're going to get a decimal answer, but type in negative radical 2 and you should get the decimals matching up just as a way to check your work so that you can get the correct, perfect, exact value. Make sure the top 2 are in radians when you type them in, or you convert these measures into degrees, and the bottom 2 are in degree mode when you type them in unless you're going to convert them to radians. Keep in mind that with any of these, they're undefined if the denominator is 0. So with the tangent value, when you see something like the tangent of 180 degrees, that terminal side is ending at the point negative 1, 0. So when you're taking the tangent of 180 degrees, we're going to get 0 over negative 1. But if you took the cotangent, you would be getting negative 1 over 0, because it would be the cosine value in the numerator, the sine value in the denominator. So just be careful with angles that are undefined. Make sure you sketch it, because that's always the best way to make sure of your work. Don't depend 100% on the calculator. That's going to be a nice way to check your work.